Good afternoon all. This is lecture number 4 of unit number 6. So in last lecture we had discussed the two cases. Case number first, that is stability analysis of an infinite slope when there is a dry soil. Second, stability analysis for the cohesionless soil with the fully submerged condition. Okay, this is the water table at the top, and this is the third case, that is a infinite slope in a cohesionless soil, that is stability analysis of infinite slope with the seepage parallel to the slope and water table which is occur at any depth. Okay, so let us consider. So this is our infinite slope. Okay, this is our infinite slope. This is the bottom layer. Okay, this is made up of hard strata, and this is the top layer. This is total thickness will be Z. Okay, and let us assume that the water table which is occur at say depth h1 below ground level, and h2 from the hard strata. Okay, so from this diagram we clearly conclude that this is h1, this is depth at which water tables occur. H2, this is depth, it means this whole section is filled with the water plus soil, and this section is dry, made up dry. Okay, so obviously its unit weight will be gamma, and here is a unit weight will be gamma saturated. Okay, so there are two unit weights will be occur in the first depth, that is at h1 depth the unit weight will be gamma, and second depth, that is h2, unit weight will be gamma saturated. Okay, so we know that the vertical stresses that can be calculated by using formula sigma v. So this sigma v, we know the formula sigma v, that is gamma into z multiplied by cos of beta, that is cos of beta due to inclined angle, and so its normal and shear components are, its normal component that is sigma v cos of beta, and shear component that is sigma v sin of beta. But in this case, as there is a two depth are there, the formula for sigma v, we know the formula of sigma v is gamma into z only, na, sigma v equal to gamma into z. So it is applicable for whole depth, it is applicable for whole depth. But here is gamma is differ for this first zone, and this first what do we say, for first height, that is h1, gamma will be different, so its formula will be gamma into h1, and for second thickness, that is h2, gamma will be different, that is we can call as gamma, this is gamma saturated, because in this portion water will be there, so this is formula will be gamma saturated into z, so into h2, and for first case that is gamma into h1, and second that is gamma saturated into h2. So your formula for now formula for sigma v here is gamma into h1, because for first thickness, that is height h1, and for second one, that is gamma saturated into h2, because formula of sigma v, that is gamma into h1. In addition to that, we have to subtract that is a unit weight of the water, that is gamma w into h2, because water will be there, so we have to subtract it, that is gamma w into h2 into cos of beta, and its normal and tangential component are, so we know that sigma n equal to sigma v into cos of beta. Okay, so if you put the value of sigma v into this formula of sigma n, so what is the value of sigma v? So this is the value of sigma v. Okay, this is third case is different than all the 5 cases. Okay, there are total 5 cases, all the 5 cases are same, only this case is somewhat different, because there are 2 heights. Okay, so if you put the value of sigma v into this formula, so our formula becomes gamma h1 plus gamma saturated h2 minus gamma w h2 into cos of beta, that is cos square beta, because into cos of beta multiply by this cos of beta, that is cos square beta. Okay, so we can also write as if we take the h2 as common, that is gamma h1 plus gamma saturated minus gamma W into H2, okay, into cos square beta. But we know that gamma submerged means, what is meant by gamma submerged? We know the formula from unit number 4, gamma submerged equal to gamma saturated minus gamma W, gamma saturated minus gamma W. So here we can write as sigma n equal to gamma H1 plus gamma submerged into H2 into cos square of beta. And similarly, its tangential component, that is tau, equal to sigma v sine of beta, okay. So here sigma v, okay, so what is the formula of sigma v? That is gamma H1 plus gamma saturated into H2, okay. So here we are not taking this term, okay, here we are not taking this term, that is gamma WH2. Reason for that, because seepage is parallel. Seepage means water level is parallel, so that's why we are neglecting this term while calculating the tangential traces, that is value of tau. We are neglecting this term. So our formula for tangential traces will be gamma H1 plus gamma saturated into H2, okay. Here we are not considering gamma W, into cos of beta sine of beta, into cos of beta sine of beta, okay. So due to seepage parallel to the slope, here we are considering only total pressure, okay. So so for this previous case, here see what is meant by this gamma what is meant by this term is called this term is called as a total stresses, and this term is called as a pore water pressure, okay. Pore water pressure, that is gamma WH2 is the pore water pressure, that is stresses due to exerted due to water. But in the second case we are considering only total stresses, that is this value, that is gamma saturated into H2, okay. And once again we know the formula for factor of safety. We know what is formula, Fs equal to S upon tau, that is the maximum shear strength upon the shear stress which is occurred upon the failure plane, okay. If you put the value of S and tau, so what is the value, what is meant by S? S means C plus sigma n tan of phi upon tau, but we know that as the soil is cohesionless, value of C will be 0. If we put the value of sigma n and tau, okay, by putting the value of S and tau, so that is sigma n, we know the value of sigma n will be equal to, it is shown by this bold letters, that is gamma H1 plus gamma submerged H2 into cos square beta, okay. So this is value of sigma n, okay, that is gamma H1 plus gamma submerged into H2 into cos square beta into tan of phi dash upon value of tau, okay. So this is value of tau, that is gamma H1 plus gamma saturated H2 into cos of beta sine of beta, okay, into cos of beta sine of beta. So by cancelling the numerator and denominator, we have, if you cancel the terms, the same terms, so so this cos of beta is get one cancel and one cos of beta get cancelled, and if so here is remaining only cos of beta term at the numerator, okay. If we take this cos of beta at this denominator, our value will be gamma H1 plus gamma submerged into H2 into tan of phi upon gamma H1 plus gamma H2 sine of beta upon cos of beta, okay. So that is gamma H1 plus gamma submerged H2 upon gamma H1 plus gamma saturated in H2 into this term, that is tan of phi upon this sine of beta upon cos of beta, that is tan of beta, okay. So if we call this is as equation number A, okay. So there is a one special case, if our water table which reaches at the top surface and seepage occurs, so here all water at the top level and H1 equal to 0 and H2 equal to H. It means that it means that so for this above case, for this case, if what will happen if this water table, if this water table is reaches at this is top, means this level, if this water table is reaches at this level, what will be happen, value of H1 will be equal to 0, because water table is occur at this level, at this level, means this which is occur at top, and value of H2 we can call as H2 equal to H. If we call H2 equal to H and H1 equal to 0 0, then if we put the value of H1 equal to 0, so if we put the value of H1 equal to 0 and H2 equal to H, so our formula of this term will be equal to gamma submerged into H directly, because this term is 0, this term is 0 as H1 equal to 0, gamma submerged into H upon gamma saturated into H into tan of phi upon tan of beta. Okay, gamma submerged into H upon gamma saturated in tan of phi upon tan of beta. That is, if this HH get cancelled, that is gamma submerged upon gamma saturated into tan of phi upon tan of beta. That is, we can also call as it is 1/2 of tan of phi upon tan of beta. Okay, that is 1/2 of tan of phi upon tan of beta, because it is occur at half the water, it is occur directly on top surface. Okay, so next case, that is infinite slope in a sand, that is infinite slope in a cohesionless soil. Once again we are taking the cohesionless soil, and but here we are considering cohesionless soil as well as cohesive soil in the sand as well as in the clay. Okay, so here is one more thing is to be mentioned, that is clay, sand plus clay. Okay, that is cohesionless soil, that is sand, and cohesive soil, that is clay. Okay, that is cohesionless soil, that is phi soil, and cohesive soil, that is C soil. Okay, that is clay is called as C soil and sand is called as phi soil. Okay, means in this case both the value of C and phi is present. In the last three cases, value of C will be equal to 0, because we are considering only cohesionless soil. So in this case we are considering cohesionless soil as well as cohesive soil. So here we are considering both the parameter, that is value of C also and value of phi also. Okay, so once again considering infinite slope. Okay, considering the infinite slope, this is the infinite slope. Okay, this is our infinite slope. So this is our ground level, this is our hard strata, this is total, this is total our slope, and the thickness of the slope is, let us say, Z. Okay, and it is inclined at angle beta, it is inclined at angle beta. So the vertical stresses called as sigma v, so its value will be, what is meant by sigma v, that is gamma into Z along with cos of beta, along with cos of beta. So into cos of beta. So why cos of beta? Due to this inclined angle. Okay, so its normal component and tangential component, that is sigma n, and this tau, sigma n will be equal to sigma v cos of beta, and tau will equal to sigma v sin of beta. That is that is sigma n equal to sigma v cos of beta means gamma z cos of beta into cos of beta, that is gamma z cos square beta, and tau sigma v sin of beta, that is gamma z cos of beta sin of beta. Okay. So by using the formula of factor of safety, we know that Fs equal to S upon tau. Okay, S is the maximum shear strength and tau means the maximum shear stress along the potential failure. Okay, so we know the formula of S equal to C plus sigma tan phi, sigma n that is normal stress tan of phi, and tau that is a maximum shear stress, that is also we have calculated value of this tau. Okay, that is gamma z cos of beta sin of beta. Okay, if we put the value, that is value of normal stress and shear stress. These are the value, that is sigma n equal to gamma z cos square beta, and shear stress, that is gamma z cos of beta sin of beta. Okay, if you put this value, that is S upon tau, that is C plus sigma n tan of phi upon tau. So here value of C will be not be equal to 0, because the soil is cohesive soil as well as cohesionless soil, means the C is there and phi is there. Okay, so if we put the values, so what will be the value of sigma n? So C plus, what is the value of sigma n? Sigma n, this is value of sigma n, that is gamma z into cos square beta along with this tan of phi, upon value of tau, that is gamma z cos of beta sin of beta. Okay, gamma z cos of beta sin of beta. Okay, so we can also write that, if we write this whole terms separately, okay, in terms of cohesive soil and cohesionless soil. So if you write in terms of cohesive soil, so its formula or its it can be written as, that is C upon gamma z cos of beta sin of beta plus this term, that is gamma z cos square beta tan of phi upon gamma z cos of beta sin of beta. Write separately, okay? separate. And if you cancel the terms, so now we are cancelling the term, so what will happen? So this will get cancelled, this will get cancelled, one cos of beta get cancelled, one cos of beta get cancelled. Okay, this term is kept it as, or write it as, that is C upon gamma z cos of beta sin of beta plus, so here is remaining term, that is 1 cos of beta into tan of phi upon sin of beta. Okay, so once again if you take this cos of beta at the denominator, so this first term is kept it as, that is C upon gamma z cos of beta sin of beta plus tan of phi, this tan of phi, so this cos of beta is coming to denominator, that is sin of beta upon cos of beta, that is C upon gamma z cos of beta sin of beta plus tan of phi upon tan of beta. Okay, so if we compare this with the first case, means factor of safety is increases due to, so if we compare with the first case, what is our first case? Our first case is only this term, this only this term. Okay, if you want to see the first case, okay, so let us see, this is the first case. Okay, so this is the first case, that is tan of phi upon tan of beta. Okay, this is the first case. From here is case second, tan of phi upon, final answer is tan of phi upon tan of beta. So here is also same. So for this fourth case, that is tan of phi upon tan of beta. In addition to that, these terms is also comes into the rule, that is C upon gamma z cos of beta sin of beta. It means that the factor of safety which is goes on increasing due to this term. Okay, so in the previous case we have stated that is the value of pi is always greater than beta. Value of, in the previous case our we concluded that value of pi, that is angle of internal friction, is greater than that is beta, that is angle of slope, means our slope will be stable, means the factor of safety is greater than 1. But in this case what will happen, factor of safety is goes on increasing. So here is the beta, here is the value of beta is greater than phi, value of beta is greater than phi, means so we have to assume the critical condition. So critical condition means, for design point of view, if you assume that the factor of safety is equal to 1, if you are assuming that the factor of safety is equal to 1, okay, 1 is a parameter, from that we are deciding the stability of the slope. Greater than that means our slope is stable, less than that means our slope is unstable. Okay, so so our critical case is, that is factor of safety is equal to 1 is our critical case. So in this case here we are going to assume Z equal to ZC, that is total depth will be equal to critical depth, that is ZC, and shear stress, that is maximum shear strength equal to shear stress along the potential failure will be equal to, and if you put Fo is equal to 1 in this equation, means this so in this one equation, in this equation, okay, if we put Fs equal to 1, okay, and Z equal to Zc, okay, Z equal to Zc, so 1 equal to C plus gamma Zc cos square beta tan of phi upon gamma Zc cos of beta sin of beta. Okay, if we multiply with the 1, means this term with the 1, okay, so what will happen, that is this term is comes to this side, that is gamma Z C cos of beta sin of beta is equal to this term, that is C plus gamma Zc cos square beta tan of phi. Okay, and if you take the C towards this side, that is C equal to gamma Zc cos of beta sin of beta, so यहाँ पे क्या हो जाएगा माइनस gamma Zc cos square beta tan of phi. Okay, that is C equal to gamma Zc cos square beta, we take cos square beta into sin of beta cos of beta minus tan of phi by solving. Okay, so C upon gamma Zc, so this term is taken in this side, is C upon Zc, this is called as Taylor stability number, is equal to tan of beta minus tan of phi into cos square beta, tan of, because this is called as tan of beta and this is tan of phi and this into cos square beta. So this term C upon gamma Zc is called as a Taylor stability number, that is Sn, that is Taylor stability number Sn. So Sn equal to what is the formula of Sn? So here is the formula, that is tan of beta minus tan of phi into cos square beta. So okay, so this is the formula for Taylor stability number. So actually Taylor stability number, the formula of Taylor stability number is this formula, Taylor stability number, that is Sn equal to C upon gamma Zc. Okay, is the formula for Taylor stability number. It is denoted by letter Sn, or some books it will be write as N, capital N. Okay, so we are here we are assuming or we are denoting the Taylor stability number as letter Sn. Okay, is the ratio of C upon gamma Zc. Okay, so for this case, for that is soil with the cohesive as well as cohesionless soil, that is C for C phi soil, its formula will be tan of beta minus tan of phi into cos square of beta. Okay, and this is last case. So in the previous case we are considering, in the first case we are considering the soil, that is cohesionless soil with the dry condition, means there is no water. Second case we are also considering cohesionless soil, but we are considering the water table, okay, which is occur at top. Third case we are considering cohesionless soil, okay, but water table which is occur at somewhat depth. Fourth case we are also considering cohesionless soil plus cohesive soil, okay, plus cohesive soil. So now last case we are considering only cohesive soil, So here we are neglecting the that is friction, that is value of phi will be equal to 0. So here we are not considering cohesionless soil, here we are considering only cohesive soil, that is clay soil. So here we are taking value of phi equal to 0. So once again, so as our regular method, we are considering our infinite slope. This is our infinite slope, this is our top strata, that is ground level, this is our bottom strata. Total thickness will be Z. Okay, angle of inclination of that is slope angle will be beta. Then the total stresses, that is vertical stresses, that is sigma v, equal to value will be gamma Z into cos of beta, and its tangential its normal component, that is sigma n, equal to sigma v cos of beta, and its tangential component tau equal to sigma v sin of beta. Okay. So see here, angle of internal friction will be 0 and unit weight of soil is gamma, and beta is angle of slope. Okay, so for the calculation of the factor of safety, we know that Fs, that is factor of safety, equal to S upon tau, that is the maximum shear strength upon shear stress along the potential failure. Okay, so we know that value of S equal to C plus sigma n tan of phi by using Mohr-Coulomb's law, and we know that normal stress, that is sigma n equal to sigma v cos of beta, that is value of sigma v is gamma z cos of beta, that is sigma n equal to gamma z cos square of beta. Okay, this is our regular case. And shear stress, that is tau equal to sigma v sin of beta, that is sigma v equal to gamma z cos of beta. So tau equal to gamma z cos of beta sin of beta. Okay, by putting the value of this in equation A, because this value of phi is equal to 0, because our soil is clay soil, okay, our formula becomes C upon value of tau equal to gamma z cos of beta sin of beta, okay, is equal. So this is our final formula for factor of safety for cohesive soil. Okay, so for once again, for critical condition, if we take the factor of safety equal to 1 and z equal to zc, that is total depth equal to critical depth, that is zc, and shear strength equal to maximum shear strength equal to maximum shear stress along the potential failure. And if we put factor of safety equal to 1 in equation 1, this 1, okay, so we can write as 1 equal to C upon gamma zc cos of beta sin of beta. If we multiply with by 1, so C upon gamma zc cos of beta sin of beta. Okay, so this C upon, once again, C upon gamma zc is nothing but Taylor stability number. This is a Taylor stability number. Okay, Taylor stability, and value of that is called as Sn. So its value of Sn equal to cos of beta sin of beta. This for clay soil, and for C5 soil, Taylor stability number, what is the formula for C5 soil? So this is formula, that is tan of beta minus tan of phi into cos square beta. And for clay soil, Taylor stability number formula is cos of beta sin of beta for C soil. Okay, so our infinite analysis of stability of analysis of infinite slope is over. So here we are discussing the 5 cases. The first case is what are the 5 cases, okay, and we are calculating the factor of safety. Okay, so there are the 5 cases. What are the 5 cases? First case is, that is infinite slope is a cohesionless soil in the dry soil. Okay, with the dry soil, that is no water table. And second case is so what is the formula for factor of safety? In the first case, formula will be tan of tan of phi upon tan of beta. In second case, the cohesionless soil with the fully submerged condition. Okay, so what is the formula for factor of safety? This formula is tan of phi dash upon tan of beta. And for third case, that is for seepage parallel to the slope. What is the formula? Formula will be what is the formula? That is a long formula, that is tan of phi plus tan of beta plus the additional term will be there. And this for C5 soil, next is C5 soil. तो अभी हमने देखा वो लास्ट केस में क्या क्या है. ओके, this formula will be same, that is tan of phi upon tan of beta. Okay, and in these two cases there will be the value of Taylor stability number. Okay, so in the next lecture we are going to discuss about the stability analysis of the finite slope. So here we are discussing about the infinite slope. Infinite slope means what? The slopes which are infinite in extent, which is having unlimited boundary, which are unlimited boundary, they are not bounded at top and bottom. So we are discussing about the infinite slope, means that is a natural slopes. Okay, natural slope, that is a hill slopes. Okay, we can say so hill slope or okay. So in the next lecture we are discussing about the finite slope. Okay, in that we are discussing about the Taylor stability number, then the steady slip circle method and friction circle method, and last is Bishop's modified method. Okay, thank you.